Hello, this is Team Jarvis's final report. The development environment that we used Spacey for our part-of-speech tagging, named entity recognition, and our sentence segmentation. And we used Neural CoRef for our co-reference resolution. So the architecture for our question generation is as follows. We basically read in an article, do co-reference resolution, as well as merge the noun chunks, as well as generate a list of our sentences tokenized. At this point, we do a rule-based pattern matching. So we came up with 15 different rules, and if one of the sentences match one of the rules, then we generate a question based on that rule. As you can see, we have various question types, and then we bucket the question based on our question type. We evaluate and score the questions in each of these buckets, and then we pull the top questions from each bucket iteratively until we generate the 20 or 50 questions that we need, at which point we return them. So the approach that we took, like I said, is rule-based pattern matching. These rules were derived from grammar patterns for each individual question type. As you can see that each of these rules is based on a variety of part-of-speech tags as well as dependency analysis. As you can see on the right, we've shown two different patterns that we used with proper noun, verb, noun, as well as proper noun, verb, which is a lemma B, and we generated questions that follow these rules. Additionally, we used word entity-based analysis for who, so we wanted to generate proper nouns, so who is Cleopatra, who is Thomas Jefferson, and things like that. And we also used co-reference-based questions at a paragraph level to generate questions like, who is she in the following sentence or the following paragraph, as another way to generate unique questions. Now that we have these questions that we generated, we have 4 different evaluation metrics. The first is a length score. So we determined that the best scores, our best questions had a length of 10, and so we scaled the penalty based off of that. Our grammar score is whether a sentence contains the subject, object, and root, and we assigned a penalty based upon the distance from the object or the subject from the root in the sentence, and we found that to be a very effective mechanism. Our rule score is based on the expected grammar of the rule. So we found that some rules generate questions with a very high confidence that they're going to be good grammar, whereas some generate some questions with great grammar and some questions with terrible. And so we had to basically determine the correctness of a rule and assign it a proper score. The final is a vagueness score, which penalized questions with pronouns. Our answer generation architecture is similar. We read in an article and do co-reference resolution on the article. And then we do cosine similarity between the article and question word embeddings, as well as we have these lists of sentences that are tokenized. At this point, we branch based on the question type. Initially, we just returned the most similar sentence based on the question embedding. However, we wanted to improve that, and so we had various approaches from filtering, ranking, as well as the answering type, as well as expanding to binary, describe, and how type questions. And then at the end, we do post-processing and ensure all the answers were sentence case. So our approach is similar. We basically have these part-of-speech tags that we're looking for based on what is in the question to what is in the sentence that we need. So for who, we really want to find proper nouns and things like that. We also realized that the filters that we use needed to be adapted based on our question type, whether we're splitting based on the root verb or whether the lemma or things like that. We also realized that there could be similar questions but different type of answers. So who is Christopher Columbus and who discovered America require 2 different types of answers. Who is Christopher Columbus? We really want multiple sentences to evaluate on. So we want Christopher Columbus is an explorer or things like that. Whereas who discovered America, we really just want a single word. And so we expanded that logic to different questions like who and what and things like that. And for our binary, we did a truth table analysis based on whether there was a negation word in our question or our answer. For our evaluation and ranking, so within each question type, rule-based ranking was used. We basically manually tuned these weights to get better answers in our sorted list. And for some of the answers, we needed to weight the answer if the sentence came at earlier in the passage. As you can see on the right, if we were asked, who is Christopher Columbus? We really want this first sentence because that's kind of our generalizable summary sentence, whereas sometimes the cosine similarity was ranked higher. And so we had to tune that hyperparameter, which we really found to be effective. And then finally, since we pre-processed our data with co-reference resolution, we never answered a question with a pronoun. Thank you.